Morning all. So today we are starting a new topic under the Kubernetes, that is namespace. So first understand what is namespace. So here we have understood this rectangle is a nothing but a Kubernetes cluster. And here you can see at the bottom there are nodes. So now new term for Kubernetes it uses as a node, but earlier it was called as a worker node. So worker node and master node. So these were the terms earlier used to refer Kubernetes cluster. So now they renamed it as a control plane. So control plane is nothing but the master node, and worker nodes are referred simply as nodes. So conceptually, it just renaming, or you can use any term which you would like to. Here you can see in this Kubernetes cluster, there are 6 worker nodes or nodes. And now just think of a Kubernetes cluster. We want to deploy multiple applications into it. So then either we want to need a segregation of a cluster, or we need to have our multiple environments like dev production. So namespace is a term which refers a logical isolation of an environment. So just like here, you can see there are the 4 default namespaces, and this cluster has been isolated using the namespace. So this part will be act as a different part from the cluster. So this is the namespace. So namespace actually logically separates the cluster. So this is the main concept of a namespace. So why it is required? So for example, multiple teams are working on a same cluster. So let's take example. There are 2 teams who are working on the same cluster, and then both teams are having a separate application. But then there may be chance like there is mm, they are having some shared resources, or they may having the same name of components. So then what happens? Let's say I create a pod nginx, and then someone also created the same component. Then the previous pod will get replaced. So then the deployment of done by the first team can be changed or modified by the another team. So it's like uh, sharing place, like when we have a parking lot. So let's say uh, in our office parking, so if your parking is already occupied by someone, then it's fine. But let's say you on lunch break, you went out with your teammates, and then someone came to the office and he occupied your parking, then you will not get the parking. So this happens in a real life scenario. The same thing, if any application in the node cluster is occupying some memory, and let's say there are in nodes like some applications are utilizing the maximum memory, then other applications which are already deployed, so that may be killed because of lack of memory. So this situation can be happen, as well as cluster is a common. So every application should get the sufficient amount of CPU memory. So how we can address that? So that's why the Kubernetes provides a term called as a namespace. So namespace is nothing but a virtual segregation of your entire Kubernetes cluster. So by default, whenever we create a cluster, these 4 namespaces are created. So the first namespace is a default. So this is a default namespace, means whenever right we have created pods, we have created replica set, we have created replication controller, but every time it was created in a default namespace. But let's say we have two applications. One application for the hosting of a online banking system, and second application is also for a online banking system, but both applications are consumed by different set of clients. Let's say we create one application, banking application for SDFC, and another for the ICICI. So now our both clients should have the sufficient number of resources, as well as uh, data must be security. So then we can create a different namespace to form a group of common items, and then namespace is useful. So here also, like you can see, there are four namespace. One is kube system. So this is also a default namespace created by the Kubernetes cluster. So what are related component system, that will be part of a kube system namespace. Then default is a namespace where all the resources will be created. And then these are the manual namespaces created, dev and production. So why this is created? For example, if any changes are made by the developer in the dev environment, so they are in testing phase. Developer has to test it functionally. Unit testing need to perform by the developer. But if we directly deploy accidentally some changes to the production, then application may get down. To avoid this, we use a namespace. We create a separate namespace for the dev environment and the production environment. So we will create this namespace using command kubectl create namespace and name of a namespace. So here we can see the name of namespace is a dev. Then we will get a message namespace/dev created. So let's say we have to create a namespace for production. We will use the same command kubectl create namespace prod. So it will create a prod namespace. So in nutshell, namespace is nothing but a segregation of cluster. So then how we can create it? So we have learned in Kubernetes, we can create resources in two ways, either imperative way or declarative way. So here, uh, this is the YAML file which we have used to create a namespace. So here we have created a three namespace. One is dev, another is QA, and third is a prod. So here we can compare what is the change between the YAML. So there is the only change of a name. Remaining components like API version, kind, metadata, everything is same except the name of a namespace. So this is a declarative way or declarative approach to create the namespace. So then what is the imperative way? So this is using the command line kubectl create namespace dev, kubectl create namespace QA, kubectl create namespace prod. So both the ways are fine to create the namespaces. So it is like if you have attentive in all lections, so you have seen to create you have to create a pod, you have to create a replica set, you have to create a replication controller or namespace. So basic are same. Here API version will be v1 for all the components except replica set. So replica set, it will be app/v1, but for other components API version is a v1. Then kind. So kind is the property which tells cluster which component you have to create. So then when we have to create a pod, we mention here a pod. We have to create a replica set. We mention a replica set. We want to create a replication controller. We mention a replication controller. And then name of that particular component. So now here, let's say we created a namespace, but how we can ensure the new resources which we are creating that will fall under that namespace only. So because we have not used such term, we are just creating a resources. So for that, we have to add one more parameter, that is namespace in our YAML file, namespace dev. So then this configuration file will create the resource. So here you can see the pod is being created. So that pod will be created in the namespace dev. Or if we are going to imperative way, then we can use the command kubectl namespace, name of a namespace. Sorry, kubectl create pod, then name of a pod, and hyphen hyphen namespace dev. So if we want to go with the imperative way, so here you can see this is the way kubectl, rather than get, we will use the create. So the result will be the same. So using the parameter namespace, we can ensure the components which we are going to create will be created under that namespace only. So then these are the operators which we do on all the components. It may be a pod, replica set, replication controller, or namespace. So just change in the name of a component. So if we have to create a namespace, we can create a declarative way using a YAML file, kubectl create -f namespace name dot YAML, and then we apply, or we can create a imperative way kubectl create namespace and name of a namespace. Then if you want to see it, kubectl get ns. So these commands will be the same. So for example, if we want to see, sometimes there is a chance, like for example, lack of resources, then namespace or pod will not get created. So to troubleshoot what happened, we use the command kubectl describe ns. So ns, you can use either ns as a short form or complete name as a name space. So both is fine. Just like we use a po for pods and no for nodes, here we can use the shortcut like kubectl create ns or describe ns, and then set ns context. So this one we use to kubectl config set context hyphen current slash namespace equal to name. So where we want to create the resources, or where we want to run the command, we use this. Just like we yesterday we edited replica set and replication controller, so we can edit that namespace as well, kubectl edit ns, and then for deleting kubectl delete ns. So at this point you must be getting confident, like Kubernetes is easy, and it is just need to understand these simple 6 commands. So using these 6 commands, we can manage pods, replica set, replication controller, and namespace. And a further component which we are going to see, that will be using the same approach for creating the components. So here we can see the command kubectl operation resource type -f file name .yaml. So this is given in a short. So these are the verbs like create, get, describe, and set, edit, and delete. So here we can just change the operation, typing the operation name, and then type of resource and -f file name .yaml if you are going to use YAML file. If you want to go imperative way, you can just type kubectl get ns -m like this. Okay. So if you are enjoying these sessions, let's move to the practical session. So before that, how we will create the resources. So as I told already, Docker desktop should be running to use this cluster. So this is simply Kubernetes.io, and so first of all, we will use this command to see the existing namespace. So we have seen there are default four namespaces active. So here you can see there's a default namespace, then kube node leads. So this is a namespace. Kube public is also a namespace, and kube system. So these are the 4 inbuilt namespaces. When we create a cluster, it will be available. So let's use this command kubectl get namespaces, and we can see there are 4 namespaces, and there is one more, that is local path storage. So this is also a new namespace created. So it is a part of a this cluster only, and it is a default cluster created, because so far we have not created any new namespace. So now move ahead. Okay, so then this is a command which we use a kubectl get namespaces and name. So we have not created any namespace yet. So let's create our first namespace. So how we can create that? So we can create using YAML file. So here you can see creating a new namespace. So create a new YAML file called my namespace.yaml with the contents. So let's copy this and open the VI editor. Insert mode, and we need to copy this. Use control insert from copying and use shift insert to paste. So here it is asking to give a name of a namespace. So we can give a name here as a testing. You can give a name of your choice. Save the file, and now use the same command kubectl get namespaces. So here we can see, okay, so we have not created it, sorry. So we have just, what we have done, we have just created the YAML file, and now we to create the namespace. So for that, we need to use the command kubectl create -f.
Hello, sir. Your screen is lagging behind. So I am facing this issue, or all of you facing issue?
No, there is no issue.
Please, is there lag for others as well?
It's not
Yeah,
lagging.
sometimes lagging. Yeah.
Okay,
No.
maybe network issue at your end then. My voice is proper, right?
Yes, your voice is proper,
Yes,
but
yes.
yes, your screen is lagging.
Okay. 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 So now you are on a Git bash screen, right? Everyone is on Git bash screen.
Yes.
Yes.
Okay, fine. So if it gets lag, let me know. So now we will use the command kubectl create -f. -f is for the file / represents the current directory. So just enter. Okay. So now here you can see I have used a name as a testing, but it is saying invalid value. Lowercase RFC label must be considered lowercase alphanumeric characters or underscore and must start and end with the alphanumeric character. It means for a namespace, we cannot use a capital letters. So it should start with the small letters. So let's go back and edit our file. And rename it as a small letters. So this is an observation which you need to remember. Okay. Now use the same command, and you can see a namespace testing has been created. So how we can see again? So we have a command kubectl get namespaces. So here remember thing, whenever we are using a get command, so it comes up plural form, like kubectl get namespaces, get replicas. But when we use other commands like create, delete, then we just use a singular form of a component. So now here you can see this testing namespace is created. So we have created this namespace as a testing. So now we have created this way, like using YAML file, or we can create the declarative way using the command kubectl create namespace. So let's create that as well. Now we will use a namespace. So this is one more thing, like when we get, because there may be chance like multiple components will be there. So we use namespaces or pods. We use a kubectl get pods, get nodes. But when we are using create, so we are creating one at a time. So we use a singular form, kubectl create namespace, and then name of a namespace. So I will name it as a staging. So now you can see this is also created. Get name spaces. You can see these two namespaces. So then move ahead and deleting a namespace. So we will see that uh, at the end, but then there are the multiple operations which we have learned. So first what we will do, so here they have directly said to delete it, but then we will not able to. So next operation is create a pods in each namespace. So now here, what is our requirement? So we want to create a pod inside that deployment. So let's try to understand first. So let's say I am creating a single pod. Kubectl create. So when I have create the pods, so what I know, I need to create a YAML files, or just type pod. So we need this YAML file to create the pods. So simply we will create this pod using this command, because we have already seen this in depth. So I will use this method to create the pods. So what I want to show you, when we are using pods, so you can see the pod has been created. Okay, but now I can see this pod has been created, but I not able to find out where this pod is created. So it's created some spaces, but I don't know where it is created. So I can use this command -o wide. So it will give me a more detail. So here you can see the name is nginx, status running, restarts, age, IP, node. So it has created on this node. I want a more details, so I can use a command kubectl describe pod, and the name of a pod is a nginx. So here we can see all the steps what have to the pod. So first events what happened, scheduled. It means schedule. Then it pull the image nginx 1.14.2 from the image repository. Then it successfully pulled the image. It took 29.965 seconds. And then this is the image size in bytes. Then it created normal container nginx, and then normal started. So these steps are helpful when we use a describe. So it shows all the event history. Okay, so now we want to see the output file. So here I am just taking for example to that you can compare these steps. kubectl get pod, name of a pod is nginx -o YAML. So now I can see the YAML file where I will get the entire details about this pod. So here you can see this is my command kubectl get pod nginx -o YAML. So this is a YAML file which is used. So here you can see the kind is a pod, metadata, kubectl, spec. In spec, I have a details of the, so here you can see a namespace. So what I wanted to show here, like when I am not mentioning any namespace, then it uses a default namespace. So here you can see the namespace is showing as a default. So we have 7 namespaces. Like when we run the command kubectl get namespaces, so this will show the available namespaces in your cluster. But when I do not mention the which namespace I want to create a pod, it used a default namespace. So here you can see -o so it is pod created and it has used a namespace as a default. But now what I want to do, I want to create that pod inside the newly created namespace. So how we can do that? So here we can do that using the file like, okay, so here is a one term deployment. So we will see that what it is in detail, but just for today's session, deployment is like when we have to deploy the application on a Kubernetes, then we use this deployment. And this deployment, so generally no one creates the pods manually, or neither we create a replica set also. So what we create is we create a deployments. So this we will see in next lecture in detail, but just at a high level overview, it will create the pods, it will create the replica set. So it will create all the components which we have learned so far. So this is a command kubectl create deployment, and here you can see -n is used for the namespace, and then replica set. So it will create a replicas. So it will create a two replica set automatically. So it will create a two pods. So this is the command. So if I use it as it is, it will give me error because we don't have the, okay, let's see what error it gives. Failed to create deployment, namespace deployment not found, because this deployment we have not created a namespace called a development. So -n is nothing but namespace. So let's change that code and use the namespace which we have created. So we have created a namespace as a testing, and now run the command. So now you can see deployment app snowflake created. So now deployment has been created. So now if you want to get the deployments, then we will use this command kubectl get deployment. Okay, but now you can see we have created a deployment, and it shows deployment app snowflake created. But when I run the command kubectl get deployment, it is showing no resources found in default namespace. Why? Because here I have not mentioned any namespace. So when I do not mention any namespace, so by default it checks for the default namespace. So how I can do that? So I need to mention the name of a namespace. So here you can see kubectl get deployment. So I need to mention the namespace, then only it will show. So what have we understood? So let's try to figure it out what we have understood. So why namespace is required? So we know this is your control plane or master node. You can call it anything, doesn't matter. So far, you should able to understand what it does. So we have learned this, and then we have a worker nodes. So these are the 3 worker nodes. Okay. So can call it worker node or simply node 1. Okay. So whenever we create any resources or any pod, so this is a line between master control plane and worker node. So here is API server and everything that controls it, the nodes. So let's say we create a deployment. So if we create the pods, like this is our pod, and this pod is created for the production environment. Okay. So, and one pod will be created for the staging environment. But, or let's say dev environment. And then both pods having the same name. So let's say this pod is running in a production, and this is serving the user. So let me give it name. So this is a production, and this is a dev. But both are having the same name as a nginx. But what happens, like for example, these pods are serving the application to the end user in production, and this is a developer pod. So let's say developer created changes, so then those changes will be get reflected on both the pods, because everything is done in a default namespace. So now we saw, whenever we create a pod or when we create deployment, if we did not mention, so it is not showing us. So if you want to see the deployment, then we need to mention the namespace. Now you can see, as soon as I mention the namespace, I can see there was one deployment created, Snowflake, and it is showing 2 of 2. It means it has created a 2 pods. So let me show you kubectl get pods. So here you can see I can see only one pod because it is showing me the default namespace. But when I type kubectl get pods -n equal testing, you can see there are 2 pods. It means what? It are isolated from each other. So how we can come to know? So like it creates a isolated environment. So now this namespace will be isolated. So then there is no chance like there will happen something wrong with that. So like this is a namespace. For example, this we can give a name as development. And this as a production. Okay. So now what happens? These pods are these both pods on the same node. but now they are in an isolated environment. So these are having a different namespace. How we can check that? We are doing the same command, kubectl get pod, but we are getting only one pod which we have created, and it is, if we are not mentioning any namespace, so it is a default namespace. But when we mention here the namespace as a testing, then it show us a two pods. So this is nothing but a virtual separation of your Kubernetes cluster. So what is your Kubernetes cluster? The entire thing, this one is called as a Kubernetes cluster. So if you consider this entire part highlighted in a red, so this is your Kubernetes cluster. So this is your Kubernetes cluster, but what we have done, this Kubernetes cluster has been isolated. So it's, you can consider like this is your machine server, and you have created a separate virtual machines. So it is the same thing. Like when we have create the virtual machines, those virtual machines are isolated from each other. They are not able, like for example, if I created this virtual machine and here it is, I can run Windows 10, and in another machine I can also run Windows 10, and I can, on third I can run Windows Linux. I can run Linux operating system. Same thing we are done using a namespace. So this entire a blue color rectangle is your Kubernetes cluster, and then we have separated pods using a namespace. So we created one for development, like for developer, another for the production, and we can have a staging UAT likewise as per our requirement. So I hope you are clear what is the namespace, and now you understood why it is required as well. Okay, so let's see the next topic. We can see this deployment has been created, and I said like when we create deployment, so it also create a replica set as so. So how we can check that? We can type command kubectl get replica set -n equal to testing. So you can see this is a replica set are also created. So what? So try to understand when we create deployment, it has created what happens. So here you will get idea. So like kubectl create deployment snowflake. So this is a name of a deployment snowflake, and then which image we have to use, that we have mentioned here. Then namespace, which namespace we have to create, we have mentioned here, and then how many replica sets we have to create here, which we have mentioned here. So replica is equal to, it means it has created a replica set of 2. So you can see desired to, current to, ready to. So that's why it created pod, 2 pods. If we modify it, how we can modify it? Changing the replicas, number of replicas. So, and we have seen the commands called edit. So we can use the same command and just use the command edit, and we will be able to edit this replica set. When we use the edit, so like this file will open. So now you can see this is showing kubectl.exe-edit. So you can see this is the YAML file of a replica set. So app is Snowflake. So this is all details. Namespace is testing. Here you can see API version is app/v1 because it is a replica set. Here you can see only replica set uses the API version as app/v1. All other components will use as 1. So here you can see replicas are mentioned as a 2. So we can change it to a 5, and it has all the details like which containers will be used, and this is showing a status. So it is showing status means current at current what is the available. So you can see here it star is mentioned. So save it and close it. So here you can see replica set.apps edited. So now use the same command, get replica sets testing. Now you can see it is still showing the 2 and 2. Okay. So it will take some time to reflect it. Okay. So let's check, does it has any replication controller? kubectl get rc. RC we can use replication controller hyphen name equal testing. You can see no resources found in testing namespace because I already told replication controller is a deprecated term. Like now no one uses it because it is the replica set has is the next version of a replication controller. So that's why it do not create any replication controller. Okay. So next part. So we create a deployment here and then we can see kubectl get pods hyphen L is nothing but a label. App equals snowflake and n equal development. So we can use this command to get the pods using a name labels. But here we have a namespace as a testing. So here we can see hyphen L. So hyphen L means, let's say we have other pods in this deployment and we want to see only the pods related to the snowflake. Then we can use this command hyphen L for label, which are labeled as a app equals snowflake hyphen n testing. So I think I have opened this one. Yes. So this was, we have opened hyphen.ml, which we was present in a default. So let's try to open the pod which are present in the, so these are the pods, right? So let's use this and see the YAML file of it. So how it look like. kubectl get pod and this name hyphen o YAML. Okay, it is not found because I have not mentioned the namespace. It is again checked for the default namespace. So I need to mention the namespace. So now you can see detail of YAML. So here I can see what are the labels which are used. So this is the command kubectl get po snowflake hyphen o YAML namespace equal to testing. So this will be same API version v1 kind pod name. Okay. Am I audible now? Hello. Please confirm if am I audible or not.
Yes.
Okay. So what we have created,
Your screen,
yeah.
you are not sharing.
Okay. So now it should be visible to all, right?
Yes.
Yes.
Of a pod. So we have taken namespace as a testing, and this is the API version given kind pod. It will be the same for all the pods. Then metadata. So metadata is nothing but the details about the pod. So it shows a creation timestamp when it was created, generate name, what name it used while created this pod, and then app snowflake labels. So here snowflake. Whenever, like for example, in this deployment, we have multiple apps, or so then we can identify using this label. So here you can see we have used a command -l. L is nothing but the labels where app is equal to snowflake. So this we have used here, and then namespace is a testing. So just observe kubectl get deployment -n equal testing. So now here, see what is the name of a deployment. The name of deployment is a snowflake. Okay. Then kubectl get rs -n equal to testing. So you can see this replica set is having the name of deployment. These are the words which are added to the replica set. Now I will do a get pod. Now you can see this has name of a deployment, and it has the same replica set, name of a replica set. You can see this is having the same name of a replica set. So both are sharing the same name of a replica set, and then some random 5 words which represents as a pod. So this is the way Kubernetes create the resources. The name of created a replica set. So the name of replica set was 5CF7. So this is some random number. And then the pods. So pods are having the name of a deployment, which part of deployment they are, then the part of replica set which they are, and then this is a unique name identified for them. So these are, see the Kubernetes. So this way we can find like from which deployment these pods are created, which replica set is managing that pod. So now let's see, we can see here desired replica set is 2, and we have created 2 pods. So let's try to delete this pod and see what happens. So you can see that pod has been deleted. So now again do the command kubectl get pods -n equal to testing. So now you can see as soon as we deleted 9LCN, it created a new pod skd87. So this is the existing pod kg2g5, kg2g5. So how it get controlled using a replica set. So what we have set here, the maximum desired 2 replica sets are required. Like at least 2 replica sets should be running all the time. So though we deleted one pod, replica set created a new pod. So now let's how we can create that pod. So here we can create the pods. Okay. So how we can create the pods using YAML file? So let's create one more pod using YAML file. For this, we can express pod as a YAML file. We can copy it and we can store it in a new file and we can create that pod. So I am using one pod kubectl get pod name of a pod -o output and YAML. Okay, I did not give a namespace. So here you can see this is a file which we will use. So copy this content, open Notepad, and so what we need a 4 components: API version, kind, metadata, and spec. So this spec are required, status is not required. So I am just deleting it. And I will save this as, or I will copy this using control insert. I can using shift insert. So I pod dot YAML. I just save that file. Okay. So I created a file. I just copied the existing pod and created in a new YAML file on my machine. And now I'm using this that to create a new pod. So how I can create a new pod using command kubectl create -f. So here I don't need to mention anything because I am going to use the file. So okay, so here you can see when we are using a declarative, so we just use the -f and create. So we don't need to mention here what component we have to create because all those details are available in this pod file. So just hit enter. Okay, so it says it is already exist because in that YAML we have not changed the name of pod. So first, either we can go and modify that YAML file or we can delete this file. So I will change the name of the pod in the YAML file. So here you can see 87 is there. Okay, insert mode. Then name of a pod is this skd87. So I will change it to 89. And I will change this character as well. Okay, so I will save this. And now I will use that command. So now you can see the pod has been created, SKT89. Let me do check the pods kubectl get po -n equal testing. So you can see SKT89, which we have created. Okay, kubectl get pod nginx. So where is that? Snowflake SKT89. So here, let's the name. This is new Snowflake template space test or reference. Okay. So here we have given all the details, but it shows the message as a created, but we are not able to see it, right? So let's find out what happened to that pod. Okay. So get pods, cannot see that pod, right? So either it has been deleted by the replica set because we have set two pods. So can confirm using the same command. Let's see if it gives the error, it is already available. So you can see it get created again. Why? Because it was deleted by the replica set. So here, the first time when we created, it gives the error like already exist. But we have created the same pod two times. You can see snowflake created. Here we can see it is created, as well as here also we can see it is created. But when we do a kubectl get pods, we are not able to see, because replica set we have set to create two pods running all the time. So that's why it is getting created and it is get deleted. So how we can find out the what happened to that pod? So we have a command called as a describe. So we'll use that command kubectl describe pod, name of a pod, and then namespace testing. So it shows it is not found because it is deleted already. So that's why we are not able to trace it. So now what we can do, we can delete this pod, existing pod, any pod of 2, and we'll create the new pod using our file. So kubectl delete pod, okay, and then, but will win over this replica set or not? So let's try. It is created ctl. Okay, so we are not able to win because as soon as this pod was deleted by the us, replica set created a new pod. And you can see when we are doing kubectl get pod and testing, then it was already created. So again, we will not able to see that pod. So if I do a describe command, so it will show pod not found. So I hope you understood how replica set works here and how we can create the namespaces. So this is a easy concept, but very simple concepts. I hope you are enjoying the sessions as we are moving ahead one by one, and it is similar command, so you don't need to remember multiple commands. You just need to rename the resource of a name and use the commands. Okay, so thank you all of you. We'll see next part tomorrow. So this was all about namespace, and hope you are enjoying the sessions. Okay, bye. See you tomorrow.
Thank you.